All righty, everyone. All right, so that was our first docking station today, the first place that we're gonna land. But we've got some really cool places to check out. So let's keep going. Let's go back to our solar system. Now, a little bit later, we're gonna come back. We're gonna visit some of these outer planets. Okay, those are our giant planets. We're gonna swing back around a little bit later. But before we do that, do you all want to see what's outside the solar system?
Maybe.
Yeah, right?
I already know what's outside.
So this is our neighborhood in space. We have never sent anything, person or machine, to leave our solar system. It's just too big. So let's fly away from the sun about 180 million miles away, where we'll reach the Oort cloud. All right, this is the true edge of our solar system. This is past even Pluto. All right, it is a huge swirling cloud of little chunks of ice that fly around the sun.
Snow.
Now, once we pass through this cloud, we've entered the rest of our galaxy. Like I said at the beginning, the Milky Way, our home galaxy, has 250 billion stars in it.
Wow.
All right, so there's a lot of really cool stuff for us to see. Why don't we visit a lot of those stars at once?
Kind of looks like snow.
We are going to set a course for our first nebula. All right, a nebula is like a giant gas cloud in space. They're kind of like clouds here on Earth, except they're mostly made of hydrogen and helium. Helium is what you put in balloons to make them float. But this cloud is also much bigger than one you'd find on Earth. This cloud is bigger than our entire solar system. All right? We call it the Orion Nebula. And it is a factory that makes stars. Okay, so inside this cloud, hundreds of stars are being born all at once. Here's how that works. Let's watch some stars be made.
Ooh.
You get little clumps in the gas. These are called protostars. They stick together kind of like a snowball. And just like a snowball, as it starts spinning and rolling, it's gonna get bigger. It's gonna pull in more and more dust, and it's gonna get hotter and hotter, until eventually it gets just hot enough to turn its engine on and start shining brightly like a star. All right, so once this happens, we can start to really see the star. And you can also see there's even smaller snowballs, little clumps forming around it. Does anyone have a guess as to what those might turn into?
Stars.
You shout it out.
Stars.
Planets. Very good. These are planets. So this is where our little neighborhood came from. There was a big gas cloud, our sun formed, it was a really, really hot star, and around the sun, all of the planets formed from the leftovers.
That's where we
There's
live.
Earth, right? So if you've ever heard we're made of star stuff or we're made of stardust, this is what we mean. We are made of the same things as the sun, which I think is pretty cool. Now, this is where stars come from. What happens when stars run out of gas, when they reach the end of their life? Let's find out. We're gonna fly to another nebula. We're gonna go to another gas cloud. Now I hear some of you saying that some stars explode, and you're right. So in order to explode, a star has to be pretty big. So our sun is not going to explode this way. It has to be 8 to 10 times more massive than our sun. And when you get a star like this, when they run out of gas, they're gonna get colder. And as they get colder, they're gonna get unstable, they're gonna get messed up, until eventually they get crushed. And when they get crushed, it sets off an explosion. All right? This is called a supernova, a star explosion. And as the stars explode outward, they send these waves of heat and gas out into space. And it leaves behind another type of gas cloud, another type of nebula.
Imagine like
So
a
let's
part of your body.
zoom in on this picture. This is the Cassiopeia A nebula. This is a real picture taken by the James Webb Space Telescope of a supernova remnant, the remains of a supernova. So somewhere in the middle, that big star exploded. And what you see, these pink streaks, are like the shock waves coming from an explosion. Imagine dropping a pebble in water, you get ripples. These are ripples made of heat and gas caused by an exploding star. So these are some of the really incredible things that you can find in our galaxy. Now, our galaxy is huge, right? It's 250 billion stars. Why do they all stay together? We're going to try to answer that question today. And to do that, we're going to swing back towards our solar system for a second, because I want to talk about the force that kind of controls space. That's the reason why things work the way they do. We are going to talk about gravity. So gravity is something we're all familiar with, even if you don't think you could define it right now, because if you jump up, what happens?
You get sucked back.
You fall back down. When you go out into space, if you jump up, you're just going to keep going where you're going. The reason we stay on the ground is because of Earth's gravity, Earth's pull. The reason the planets stay going around the sun is because of the sun's pull, its gravity. But to really understand gravity, let's look to our outer solar system. We are going to go to the second gas giant planet. We're going to visit Saturn. And Saturn can teach us a lot about gravity. Because Saturn has rings. You've all heard of the rings of Saturn, right? Now, the rings of Saturn look solid from way out here, but it turns out they're actually not. They're made of little tiny chunks of rock and ice that swirl around the planet incredibly fast. Now, the reason these rocks go around Saturn is because of its gravity. Saturn is big, right? It's got a lot of stuff inside of it. The more stuff you have, the stronger your gravity is. So Saturn has a lot of stuff. These little rocks don't have a lot of stuff, so they get stuck going around Saturn. Now, the rings of Saturn were created when two moons that were orbiting Saturn, they were flying around the planet, crashed together. And as those moons exploded, all of those bits and pieces got swept up in Saturn's pull. Now, it might seem a little sad that Saturn had to lose two of its moons in order to get the rings, but the good news is that Saturn has the most moons in our solar system. Saturn has 146 moons. That is a lot of moons. Now, some of the moons are actually inside the rings. We call these shepherd moons, and they act like snow plows. Their gravity picks up rocks along the way, creating these gaps. Now, let's go to one of the moons just outside the rings of Saturn.
Death Star.
That's no moon. That's a Death Star from Star Wars.
Guys,
All right, so hopefully, as far as I know, the Death Star is not hanging out around Saturn. There is a moon here. We call it the Death Star moon. Pay attention to this crater because the real moon here is Mimas.
Oh, what?
It kind of looks like the Death Star. It's got that big crater on the middle. But it turns out that we didn't have a picture of this moon until after Star Wars came out. So it's just a coincidence, but it is quite fun. Now, Mimas is a large moon just outside the rings of Saturn. So do you think Mimas has gravity, yes or no?
No.
I heard some people say it does have gravity. Anything that has stuff inside it has gravity. Do you all have gravity? What do you think? Yes, we have gravity. Now, does Mimas or Saturn have more gravity?
Saturn.
Saturn, right? Because Saturn's a lot bigger. Which means that Mimas's gravity tugs on the rings. It tries to pull the rings away from Saturn, but because Saturn is bigger, it holds on to them. Mimas does help keep those rings looking really pretty, though, by pulling on it from the outside. Now, let's go to the largest moon of Saturn. We're going to go to Titan. Now, Titan is a moon that is about the size of the planet Mercury. All right, so this moon is planet-sized. It is really big, not quite as big as Saturn, though. Now, Titan is the only moon we've ever found with a thick atmosphere, okay, with clouds, basically. The clouds on Titan are 2 times thicker than Earth's clouds, which is really, really interesting. Titan is also the only moon in our solar system, the only moon we know of, that has standing water, or standing, not water, it's liquid on the surface. Titan has lakes. But the lakes aren't made of water because Titan is negative 290 degrees Fahrenheit. Okay, what happens to water if it gets to negative 290 degrees? It freezes, exactly. So the lakes on Titan are actually made of ethane and methane. But that makes Titan a really cool place for us to study, and also a really cool place for our second roller coaster ride of the show. So we're gonna get a chance to ride a roller coaster on Titan. Once again, this is an opportunity for pictures and videos. Just keep your flash turned off. If you get motion sick, just close your eyes and look down. And of course, it is a roller coaster, so feel free to stick up your hands and scream. All right. Now, you might notice this roller coaster is floating. This is only possible because of Titan's atmosphere, because of those clouds. That's how we get balloons to fly here on Earth. And we are flying over those really cold ethane, methane lakes. Please enjoy your ride on this moon of Saturn.
I hope we totally don't crash into the Imagine that actually happened. Quite shaky. Whoa. Oh my! We're going up. We're going up.
Oh God, I don't like this.
We're done for.
No.
I hope you guys have the best life. Had the best life. We are.
Alrighty, everyone. How was your roller coaster ride on Titan? Alrighty.
Yeah, that was
It got
All
too
right,
long,
everyone,
so I
so
have to
this
cut this part out.
was another really cool place